Now we see a problem in harmonic oscillator which is related to representing a position and momentum operator in terms of matrix. The problem is for a one-dimensional harmonic oscillator, the creation operator A tagger acting on the nth state of wave function, that is ket psi n, where n is equal to 0, 1, 2 gives A tagger ket psi n is equal to square root of n plus 1 ket psi n plus 1. The matrix representation of the position and momentum operator x equal to h cross divided by 2m omega square root into a plus a tagger, and p is equal to I square root of m omega h cross divided by 2 a tagger minus a for the first three rows and columns is. So this is the gate questions. They have asked for position operator. I have included momentum also. So for one-dimensional harmonic oscillator, the position can be represented as square root of h cross divided by 2m omega into a plus a tagger. And the momentum operator is represented as p is equal to I square root of m omega h cross divided by 2 a tagger minus a. And you know, a and a tagger are annihilation and creation operator. It's also called as ladder operator. In one case, A is a lowering operator and A tagger is a raising operator. So it is also called as ladder operator. When A tagger acting on the ket psi n, it is equal to square root of n plus 1 ket psi n plus 1. Similarly, when A acting on ket psi n is equal to square root of n ket psi n minus 1. So if you multiply with the Brown notation psi n plus 1, you can get it is psi n plus 1 a tagger ket psi n is equal to square root of n plus 1. And similarly, if you do it for a, if you represent this in terms of matrix, it is n. Instead of psi n plus 1, you can represent it as n plus 1. So it is n plus 1 a tagger n is equal to square root of n plus 1. And for a, it is a n plus 1 is equal to square root of n plus 1. For all other combination, it is 0. Okay. So if you take n varies from 0, 1, 2, 3, etc. So it is concentrated on 3 rows and 3 columns. So if you take the first element, it is 0, 0. That is, in the block case, it is you have to take 0 and the ket it is 0. Okay. And generally this will represent row and this will represent column. So it is 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So these are all the different combination. But only with if you take a tagger, it is n plus 1, n have the value. And for a case, it is n and n plus 1. So if you take a tagger, 1, 0 and 2, 1 has the value, all other element have 0. If you take a, it is 0 and 1 and 2 has the value, all other elements are 0. So if you take a tagger and if you take that value 1 and 0, that is in one case n plus 1 is equal to 1 and a tagger and n is your 0. So if you represent this a tagger acting on 0 is square root of 1. So square root of 1, 1 and 1, so it is equal to, this is like delta of 1, 1, so it is equal to 1. So if you take 2 and 1, so that is the n plus 1 is your 2 and a tagger 1 is equal to square root of 2 and this is your delta 2 2, that is equal to 1. So the answer is square root of 2. Suppose if you take another case 1 comma 2, so in that case it is 1 a tagger and 2. Okay, so a tagger acting on 2 is your square root of 3 and 1 and 3. So here it is delta of 1 3. So delta of 1 3 is equal to 0. Similarly, if you do it for 2 2, so it is 2 a tagger 2, that is equal to a tagger acting on 2 is square root of 3 and 2, 3. So it is like delta of 2, 3, that is equal to 0. So only with the element, only with this 1, 0 and 2, 1 has the value, all other values are 0. So it is the matrix element for A tagger is 0, 0, 0, 1, 0, 0, 0, square root of 2, 0. Similarly for A, it is n plus 1 is equal to square root of n plus 1. So here also it is 1 and 2. 1 represents your row and 2 represents your column. So it is 1 A 2. If you this A acting on 2, it is square root of 2 and 1 1. It is delta of 1 1 is equal to 1. So it is square root of 2. And the next case 0 1 combination, that is 0 A 1, you can square root of 1, and it is delta of 0 0, that is equal to 1, so it is 1. And for 1 0 it is equal to 1. If this acting on this, it's equal to 0. And similarly for 2 comma 2, it is square root of 2 delta of 2 1, that is equal to 0. So only with 1 2 and 0 1 has the value, all other values is 0. So A is equal to 0 1 0 0 0 square root of 2 0 0 0. So if you take tagger on this A, then you can get that A tagger. Okay, so it is transpose of that. Next, using these two A and A tagger, you can find out the position operator. X equal to square root of h cross divided by 2m omega, matrix element 0 1 0 1 0 square root of 2 0 square root of 2 0. Similarly for the position momentum operator, it is P is equal to I square root of m omega h cross divided by 2, 0 minus 1 0 1 0 minus 2 minus of square root 2 0 square root of 2 and 0. Okay, here x tagger is equal to x and p tagger is equal to p. So if you take tagger on both sides, then we can get the same value of x. Similarly, if you take tagger on both sides of p, we can get the same value of this. So x and p are Hermitian operator too. Thank you.